Right, good day also. The first thing that we're going to have a look at in terms of advanced functions is domain and range. You'll see over there your domain is the x values of the function and the range is the y values of the function. So we're trying to understand, for example, this is a parabola. So if we want to have a look at the x values of this particular function, you'll notice that with a parabola it's going all the way to the left and it's going all the way to the right. So in other words, the x values, the domain in this particular case, it's either going to be, you can say x is basically all your real values, or it's basically going to be from negative infinity to positive infinity. So x is an element of negative infinity to positive infinity. When it comes to the range is your y values. So if we're going to do our range is basically going to be, it ends here if you think about it. So if you think of this is your y-axis, so your y value here is -5. So it means it's going all the way from here all the way up to infinity. So in this case, your range is basically going to be, there's two ways to write it, by the way. It's basically going to be y is an element of, now in this case it includes -5, so it's going to be a square bracket. But we're always going from the lowest to the highest, so we'll start with -5 and then basically goes to infinity. So it basically includes infinity as well. The other way for us to write this is basically y is basically greater than and equal to -5. So that's basically your answer, because it goes to infinity. So that's, but the way I'd probably write it is that I have the greater than or equal to -5 on the side over here. And then the same thing in this case here, you know, x is basically an element of all the real numbers, or x goes from negative infinity to positive infinity. Okay, everybody, I just wanted to clarify something in that when it comes to the square brackets, it means included. When it comes to the round brackets, it's not included. The only exception seems to be that when it comes to our infinity, we're always going to make that the round brackets. So in our example, in this example over here, you'll see that you've got 2 and -3. So it basically means that the range includes that -3, because remember, my range is basically going from here and it's going all the way up. So it starts by -3 and it goes to infinity. So the two ways in which I can display this, I can say that y is an element of square bracket -3. So the square bracket and -3 applies to that first value over there, and then it goes to infinity. Okay, but this refers to this doesn't mean x and y now. This is just referring to y. And then the other thing is basically, I could have written it like this. I could say y is basically greater than and equal to -3, and basically y is less than and equal to infinity. Okay, so that's important over there. Or y is just less than infinity. Less than infinity. Right, so I trust that makes sense to you guys. Right, good day all. If you can please complete this exercise for me on domain and range. In each case, indicate the domain and range of the functions below. Please pause your video, and after that you can check your answers. Okay guys, so if you did domain and range, these are the answers over here. You'll see that for the straight line, you've got y is an element of the real number and x is an element of the real number. So that would basically be, remember, your x values is always going to be your domain, and that is going to be your range. By number 2, you'll see that x is an element of the real numbers. We say that for parabolas, normal parabolas, that would be the case. Not for your inverse functions though. And then you'll see that your range is basically, the highest it goes to is 4. So y is less than or equal to 4, and we can either write it like this, or we can say that y is an element of negative infinity to 4. And then number 3, for the exponential function, you'll see that y is an asymptote there. So it means that it's going from 1 to infinity. But what's important here, we could also have said that it's basically where your range could be y is greater than 1. But because of the fact that it doesn't include 1, you'll see that we basically use a round, bracket over there. And then by number 4, in this case here, apologize, earlier on there wasn't the line over here, but that was my intention. So you'll find that your domain is x is all your real numbers except for -2, and your range is all your y numbers except for -1. There is another way for you to write this. For example, you could have written that x is greater than -2, but x is basically less than -2, and x is greater than -2. So x is less than -2 and x is greater than -2. And you could have also done it in the other particular way in which you would have done it. So thanks for that. Okay, another question that they can ask us when it comes to our advanced questions for functions is to find the values of x for where fx is greater than or equal to gx. So find the values of x for where fx is greater than or equal to gx. So the first thing to identify is you have to have the points of interception, right? So number 1 is you have to have your points of interception. Now in this particular example, I've given you the points of interception, or we have the points of interception. So if you don't have the points of interception, remember you have to use simultaneous equations. You only do that if the points are not given, or you can't find another way to find the points of interception. So in our case, we can see that our points of interception is basically over here, and it's over here, right? So when we speak about find the values of x, so x is basically over here. That's my x-axis, that's my y-axis. So they want us to tell us what are the values of x for where fx is greater than gx. When we speak about fx and gx, we're talking about where the one is higher than the other one in terms of our y values. So if we have a look here, and I'm just going to use another color to show you guys where that's the case. I'll use a light green for this one. So if we have a look here, fx is the straight line and gx is the parabola. So fx is basically higher than gx over here. That's the only place where fx is higher than gx, because it's the y values for fx is greater than the y values for gx. So that means that the x values would basically be over here. It's from here to here, right? So this is basically the area where you'll find that your fx function is greater than your gx function. So firstly, once we have our points of interception, then number 2 is we've got to identify the area, or locate the area where the one function, where that condition is satisfied. So you're going to locate the area on the quadrants, or the axis on the quadrants, or the on your graph where the condition is met. So the condition that we're talking about here is where is fx greater than or equal to gx. So in our case, we can see that our answer is basically going to be where x is greater than the x value over here is -3 and the x value over here is 0. So it's where x is greater than or equal to -3. In this case, we're using the equal to as well because of the equal to sign over there. And it's where x is less than or equal to 0. So that's the one way we can write it. The other way we can write it is where x is an element of, now in this case, remember it's including, so it includes -3. And it goes to 0, but it includes 0. So in this case, in both cases, we have to use the round brackets. Okay, so I trust that that makes sense to you guys. Okay guys, so what you'll notice is that it's this whole area over here. I've indicated it in brown. So greater than is always to the right. Greater than is always to the right. Less than is always to the left. And that's why you'll see that it's where x is greater than. That open brackets there means open arrows means greater than and equal to. And it's less than or equal to 0. So I hope that that makes sense. So it's this whole area over here that I've indicated where the one function is greater than the other function. I hope that kind of makes sense to you guys. Okay, so in this example over here, we want to try to find the value of x for which fx is less than or equal to gx. So if we have a look here, fx is basically going to be our straight line. Gx is our parabola. So if x is basically greater than gx, if you notice it's greater than gx in this area over here, I'm just going to find a nice color to help us out, maybe pink, yeah. A nice light pink can help us there. So you'll notice that it's basically in this area over here, right? And it's also in this area over here. So in this case, it's basically going to be, my answer is going to be, it's where, and there's different ways for me to write it down. I can write it down and say, it's where x is going to be less than 0. Now in this case, there's no less than and equal to 0. So it's just less than 0. And where x is greater than 4. So you'll see it's where x is less than 0 and where x is greater than 4, because my x value over here is 4 and my x value over here is 0. So that's basically x equals 4 over there. So that's basically my answer for this particular question. Okay everybody, if you can please do this exercise for me now. I'd like you to find the values of x for number 1 and 2. And we'll do the answers after you've done it. You can pause it now. After you've done it, you can check whether your answers are correct. Thank you. Okay. Right, so let's have a look here quickly, guys. So once again here, it's about trying to find out where you have to locate it. So they've given us the points of interception, so we don't have to use simultaneous equations to find it. But here it's where fx is greater than or equal to gx. So fx is over here, right? So it's basically in this area over here. So that's another way to look at it. It's in that area over there, and it's in that area over there, right? So once we've identified the area, then we can get our answer. We can say it's basically where x is greater than, or we can start by less than. X is less than -2. Because of the equal to sign, it's less than and equal to 2. And it's where x is greater than 4, greater than or equal to 4. And over here, by this one over here, the number 2, my answer is going to find the values of x for which fx is greater than gx. So once again, sorry, less than. So less than. So it's less than gx. So it's going to be in this area over here, because it's in that area where fx is less than gx. But in a way, we've got to actually look at it like that. So it's here. So it's in this area over here. Okay, so that means that I just don't want to go past that line over there. So if I look at my answer now, it's basically where you've got x is greater than -5, because that's the x value over there, the -5, and x is less than 0. Okay, so that's basically my answer for those two sums. And then I just made one mistake earlier on. I just wanted to make sure that we correct that mistake. I don't want to have any confusion with regards to the square and the round brackets. So the mistake I made earlier on, guys, is where we said that x was greater than or equal to -3, x was less than or equal to 0. So that should actually be square brackets, because it needs to include -3 and it needs to include 0. So the answer that I had earlier on, which is incorrect, was negative. I had that bracket, so this is incorrect, and that's the right answer. So thanks for that correction that you sent through, Tashreeq.